Hello, Algebra 1 students. Welcome to your third lesson in Topic 8, Polynomial Operations and Factoring. We're spending the first half or so of these lessons really focusing on adding, subtracting, and multiplying. That's your goal 22, and it is essential here. We do need to be able to do this by the end of this unit. So we're actually going to backtrack a little bit at the beginning of today because we need to compare a couple issues that students run into when they're multiplying these polynomials or just multiplying numbers and variables in general. Today actually isn't going to be much new. In fact, there's very, very little new, and I think it'll be a little bit quicker than the last video. I know you're very sad about that. So without further ado, let's get started. Our opener, again, is a throwback. This opener actually comes back from topic 6 when we first learned about exponents. And there are a few rules we needed to remember. So you might look at this and say, oh, well, this kind of looks like what we did last class. We know that there's multiplication in between each of these parentheses, and you're 100% right. But with last class, we actually had two sides that were multiplying of a rectangle, and each side was in parentheses. And so I'm going to erase this. You don't have to draw it. If you had a rectangle here, you could still think of this as length and width, but your length would be x squared and your width would be x cubed. And so you wouldn't be splitting this into smaller bits like we did last class with those algebra tiles. Instead, there's just one square here. And so to get the final answer, you just multiply these together. In fact, what we're going to do with each of these is realizing that there's no addition or subtraction with any of them, and all we're really doing is we're just multiplying x squared times x cubed. You can actually drop the parentheses here. So I'm going to do x squared times x cubed. Now, this is directly back from topic 6.1 when we learned how to multiply variables with the same base in different exponents. There was a shortcut here, but I'm going to show you the long way around first. We know that, of course, x squared is x times x, and x cubed is x times x times x, and those two factors are separated by multiplication. So we count and say how many x's are multiplying here? Well, there are 5 x's multiplying. This is just x to the 5th. And so we might even remember that the fast way to do x squared times x cubed is just keep the same base, add your exponents together, and that gives you x to the 5th. So knowing that, or remembering that, why don't you guys try the other 5 problems here? They're all very, very similar to this, just adding a few more numbers in each time. And then once you're done, you can unpause and check your work. Good luck. All right, you are back. Let's go ahead and see the rest of these. You could have shown a lot less work than I'm about to show here. The first thing I'm going to do is drop those parentheses, and I'm going to put the multiplication signs in between each of these. This one, we don't need much work at all. The 2 is going to stay, and we know that x squared times x cubed is x to the 5th, and I think we're set. Okay, our third one, we have 2 times x squared times 5 times x cubed. I'm going to quickly rearrange the order. Multiplication, you can rearrange the order. 2 times 3 times 4 is the same as 3 times 2 times 4. It doesn't matter the order you write this multiplication. So I'm going to do 2 times 5 times x squared times x cubed. And I think 2 times 5 will give us 10. X squared and x cubed gives us x to the 5th. A couple more, and you can see that each problem is really just building upon the last, right? We have that x squared, x cubed in every single one of these problems, just adding a few more factors in there, right, separated by multiplication. So we have 2 times x squared times y times 5 times x cubed, and a little bit of rearranging, x squared, x cubed, and y. I forgot my 5, awkward. Come back to us 5. There we go. 2 times 5 is 10. X squared and x cubed is x to the 5th. And poor y doesn't have anything to multiply by, so it just says, well, I'm still out here multiplying. And we usually just don't even put the times at the end, so we just keep the y. There's nothing wrong with putting the multiplication dots. Again, your answers on a multiple choice test are always going to leave those dots out, though, because they try to write the fewest symbols on their paper as possible. They're like, you could put times, but you could also leave them off, and that's less typing or writing for us, so we're going to leave them off. Okay, last couple. I think you get the idea here. I'm just going to quickly rearrange this. So we have a 2 and a 5, x squared and an x cubed, a y, and a y to the 6th. We know that 2 times 5 is 10. X squared and x cubed, we should be pretty comfortable as x to the 5th by now. What about this guy? Is it 0 plus 6? 1 plus 6? Well, write it out. So if you take these two over here and quickly write it out, you have the y, and then y to the 6th is 1, 2, 3, 4, 5, 6. This is the same as y times y to the 6th. How many y's are there? There are 7. And that is because we learned in topic 6 that if there's no exponent written, there's always an invisible 1. And so that will give us y to the 7th. Or putting this all together, 10 x to the 5th, y to the 7th. Last one. Here we go. So let's just rearrange first. 2 times 5, x squared, x cubed. I tried to go in alphabetical order, so I did the x's first. Now I'm going to do the y's. And then everyone's favorite z, or z, depending on where you are, at the end of this. Right. And I bet we can get the answer pretty quickly. 10 x to the 5th, y to the 7th, and z at the end. Ta-da! Now again, this is all review. You're going to do a little bit more of this for your independent practice tonight, but I think it's very important to A, remember what we've done before, and B, see how this is different from what we did last class. So last class, we also had multiplication, right? We had 2 sets of parentheses, just like we did up there, with multiplication in the middle. So how come we had to use that weird box method last class, and we didn't on the opener? And hopefully you're realizing that it has to do with the addition and subtraction that's inside of here. Yeah, if you have that addition and subtraction, things get a little bit trickier here. And so for the first couple problems, we really are going to practice with that box method. We're also going to bring in what you learned in 8.1, which is writing your answer in standard form, identifying the degree, so the largest exponent, and the leading coefficient. Okay. So for each of these, you're going to want to build a box. Your boxes might be different sizes. I can help you out with that first one, right? It's nothing too bad. You've got your box right here. Make sure to leave room on the top and that left side. And you can use these other sides if you want, but traditionally we use the top and the left, so might as well. And then don't forget that your x minus 1 can either go on the left or the top. For some reason, I usually end up putting the first one on the left side, but it's up to you. We like to group the x's on the upper left corner, and there's a reason for that we'll see later on. Okay, 3x and a positive 1. And then our answer, of course, is going to be the area, because when you multiply 2 factors, you can always think of that as the area of a rectangle. So work those out. Let's see what you guys can do. And then we will come back together and share out our answers. Ready, set, go. All right. Well, hopefully you found some success. I'm going to do this entire first problem the kind of standard way moving through. And then for the other 3 problems, we're going to see if we can extend our understanding a little bit. So let's work this out. So we have 3x times x. And actually, that's very similar to what we did up above, right? If you do 3x times x, that's 3 times x times x. That's going to be 3x squared. Okay. X times 1, well, we just write that. And you could write it as x times 1. However, traditionally we write the number, the coefficient in front of the variable. So we do 1x, or just 1x without the dot. 3x times a negative becomes a negative 3x. And negative 1 times positive 1, we're not going to get 0 here. You're not going to have 0 area. Negative 1 times positive 1 is negative 1. All right, to put this in standard form, we're going to take our largest exponent first, which is that 2 right there. And so that tells us 3x squared needs to go first. You'll notice on this diagonal we have some like terms. And this is where we do add or subtract like terms. We have 1x and we're taking 3 away. That gives me negative 2x's. And then, last but not least, we have this little negative 1 hanging out at the end. And that's it. 3x squared minus 2x minus 1. The degree of this trinomial, 3 terms, right? The degree of this trinomial is 2. And the leading coefficient, the number that's in front of the variable with the largest power, is that 3 right there. Now, what I'm actually going to challenge you to do on 2, 3, and 4 is to see if you can determine what the degree and the leading coefficient are going to be right at the beginning, without even drawing the box. Because on this first one, we took x and 3x, and those guys combined to make the first term. So if we look at 2, there's a bunch of combinations here, right? This negative 2x is going to multiply by everything in the second set of parentheses, and the 3 is going to multiply by everything over there too. But what's going to make the largest exponent? And hopefully you're noticing it's probably going to be these two guys, right? Negative 2x is eventually going to multiply by x, and that's going to give us negative 2x squared. That is certainly the highest exponent we're going to get. It's a degree of 2, and the leading coefficient is negative 2. Now, let's actually do the box method. But using these shortcuts are a nice way to speed up your test-taking skills, because if you don't have to do all the math, and you can still come up with the answer if you're just asked for the degree and the leading coefficient, then you're doing pretty darn well. Now, setting this up, we are going to take that negative 2x and our positive 3, and also the x and the minus 1, and we're going to multiply. So we get negative 2x squared, positive 2x, positive 3x, and negative 3. Negative 2x squared starts us off. Like terms, they're both positive. If they're both positive, you can put pluses in front to help you out. 3 plus 2 will get you 5 of those x's, and then minus 3 at the end. Let's try 2 more. Okay. Can you guys see what the largest term is going to be here? Right? Notice that x doesn't have parentheses around it. You can put it around it, though. So when we multiply, I think x is really going to multiply by everything in the second set of parentheses. And the largest exponent is going to occur when we do x and multiply that by 3x cubed, isn't it? That's going to bump this up to become 3x to the 4th power. My degree is 4, leading coefficient is 3. Let's try the box, though. So box method-wise, I think traditionally, I usually go this way, so I'm going to go outside tradition and try it the other way. I'm just going to go like so. We're going to put x on top, and then we have 3x cubed, 4x squared, and minus, I'll put the 1 in front just to make things a little bit more obvious, and then split up this box. 1x times 3x cubed, 1 times 3 is 3, x cubed times x is x to the 4th. 1 times 4 is 4, x times x squared is x cubed, and 1 times negative 1 is negative 1, x times another x is x squared. And then there are no like terms here, which is pretty nice, so 3x to the 4th will start us off. 4x cubed is positive, so we put a plus coming next, and negative 1x squared finishes us off. Last one. Oof, lots of combinations here. Can you see how many multiplication problems we're going to have to do here? Right? We're going to have a box that is 2 in one direction and 3 in another. 2 times 3 means we're going to be doing 6 multiplication problems. But out of those 6, can you see the combination that's going to create the largest exponent? Yeah, and I think it's again going to come from these first 2 right here. So we're going to have to do x times 2x squared, and that's going to get us 2x cubed. So I think 3 will be the largest power, and its leading coefficient is 2. Let's set this up. Okay, so however you'd like. I think in terms of room, I'll work this way this time. We're going to need to put x plus 3, and then also 2x squared minus 4x and positive 3. Can we see those 6 areas, those 6 multiplication problems? Let's get to it. So it'll be 2x cubed. Do the last box. 3 times 3 is 9. And you'll notice that these don't have any diagonals. They won't have any like terms. But since these are diagonal, probably like terms, probably like terms. Let's see if that's right. We have x times negative 4x. That's negative 4x squared. And then we have 3 times 2x squared is 6x squared. Yeah, those guys do look like terms there. We'll have to combine them eventually. I'll put the plus in front of the 6 so we can see the math. And then we also have, of course, 3 times negative 4x is negative 12x, and x times 3 is 3x. Can we see our like terms again over here? Okay, and then we finish off with standard form. 2x cubed, largest exponent. Like terms, 6 minus 4 is positive 2 of those x squareds. 3 minus 12, notice I always start with the positive or the bigger of the numbers. 3 minus 12 is negative 9x. And of course, the loner 9 doesn't just sit right next to it, it's a positive 9, so we show that it's adding 9. Not bad. Now, hopefully this kind of re-solidified, or solidified in the first place, that multiplication that we did last class. Okay, so I have 2 extra problems for you, and these last 2 are a little bit trickier. So go ahead, try them, and then if you get stuck, come back and I'll at least show you the setup, and then we can go from there. Ready, set, go. All right, so let's talk about 5 first. 5 is a little bit weird because we have this minus connecting multiplication and multiplication. So in fact, what we need to do is we need to maintain that minus. It's still going to be there until almost the very end. But we have 2 multiplication problems we need to do. So I'm going to do this first one in black, and I'm going to, just to try and save a little bit of space here, do it this way. I have to do x times x minus 7. X times x is x squared, x times negative 7, negative 7x. And so we have 2 terms for the resulting multiplication, x squared minus 7x. Don't forget this minus is still here, it's hanging out. Let's go ahead and tackle this guy, and I'll do it in green. Okay, so over here we have a 2 by 2 this time. We have 2x with a positive 1 and an x with a positive 3. Put the 1 in front if you need to see that. 1 times 2 is 2, x times x is x squared. 2x times 3 is 6x, 1x times 1 just stays 1x, and 3 times 1 stays 3. So in terms, or rather with like terms, we have 2x squared, no like terms there, diagonal, both of these are positive, so 6 and 1 makes 7, and then this 3 is positive as well. Now we have something that really brings us back to lesson 8.1, which was adding and subtracting polynomials. However, you might remember, you might notice something here. I've actually made a mistake. Can you spot it? My mistake is that technically I want to do x times x minus 7, that answer, and I want to subtract this entire answer from it. Right now, I am doing x squared minus 7x, but I'm only subtracting 2x squared because the negative, the minus, is only attached to the 2x squared. That needs to go with everything over here. And so I'm using these square brackets, which I guess can be a little bit confusing. I'm really just using them in place of parentheses, just so you can tell on your paper. So if you'd prefer to put parentheses, you totally can. Right? We have to do x squared minus 7x minus all of that in green. And do you remember from 8.1 what we have to do? We can drop the parentheses for the first one because there's that invisible 1. But for the second one, I need to take this negative 1 and actually distribute. And a negative sign multiplying reverses the sign of everything it multiplies by. So positive 2x squared becomes a negative, positive 7x is a negative, and 3 is also a negative. Once you've distributed, now you can drop your parentheses and start combining your like terms. This is where we use those shapes. I have one of these x squareds, and I'm taking 2 away. That gives me negative 1 of those x squareds, and I'm omitting, I'm not writing the 1. Then I have negative 7x's minus 7 more is negative 14x's. And I've got this cute little 3 just hanging out at the end, and it's a negative, so minus 3. So the degree of this trinomial is 2, largest exponent. The leading coefficient is that negative 1 that I didn't write earlier. Okay, let's try one more. 6. X plus 2 times x minus 1 times x plus 3. Well, if you're very visually creative, you could do all of this in one box. Except your box would have to be 3-dimensional, and that would be, I think, pretty tricky to draw. So instead of one box, we're actually going to need 2. Now, there are a few different ways to do this, and I want to make sure you're comfortable with the process. So, looking at this, x plus 2 is being multiplied by x minus 1, which is also being multiplied by x plus 3. And we need to realize that this can be written in multiple different ways, right? I could write this as x minus 1 times x plus 2 times x plus 3, and that's the same thing. I just switched the order of the multiplication. I could also write it as x plus 3 times x minus 1 times x plus 2. Right? In fact, there are, I think, 6 different ways we could write this. And what that means then is when we go through and multiply this out, there are 6 different correct ways that we could start this problem. The way we need to start the problem, though, and I'll work with the original one up here, is we need to multiply 2 of the 3 factors. And I think traditionally you guys will probably just multiply the first 2, which is great. There's nothing wrong with that, and that's what I'll do as well. Realize, though, you could have decided to multiply the last 2. You could have been really exciting and multiplied the first and the last if you wanted. There's nothing wrong with that either. Okay? So I'm going to multiply the first 2 first, and x plus 3 is just going to tag along in a bit. So let's show the work here. So we have x plus 2 and x minus 1, and when we multiply, x squared minus 1x, positive 2x, and negative 2. And so I'm actually going to go off to the right over here, a little bit different this time. So my x squared is going to be here. 2 minus 1 is going to give us positive 1x. And then this minus 2, I know the minus is kind of hard to see, is right here. Now this is multiplying by that x plus 3 that I haven't used yet at the end. Can you see where I went wrong, though? Yeah, it's that parentheses thing again. Right now, only the negative 2 is attached to the x plus 3 by multiplication. I need to multiply this entire answer by x plus 3, and to show we need the entire answer, you do need to group in parentheses. Once we're here, this problem is actually very similar to the problem we did up above, right? It's a 2 by 3 array, a 2 by 3 box. So let's get it done. This time I'm going to do the box this way, just to make sure I don't run out of room. Something like that I think will be all right. I'm going to put the x and the plus 3 at the top. Then we'll split this into decent thirds or sixths, right? A half cut in third. And so then we have our x squared 1x minus 2, and we multiply. So x squared times another x gives us x cubed. X squared times 3 is 3x squared. 1x times another x is 1x squared. 1x times 3 is 3x. Negative 2x and negative 6. And our final answer. X cubed shouldn't be too bad. That's a degree of 3, and the leading coefficient is the invisible 1 that's there. Okay, we got that one. Check out the diagonals. There's positive 1 and positive 3 of those x squareds. That gives us 4x squareds. Then we have positive 3x's minus 2x's is 1x, and the minus 6 hanging out at the end. So we just have a polynomial. Looks like this. Nothing too bad. All right. The last part of today, seriously, before you guys get a chance to work with each other, is just giving you a different way you can do the multiplication. Okay? This array or box or area method that we've been drawing that we tied into the algebra tiles is awesome. And in fact, many of you will continue to use that method, and you should. It's great. However, some of you would prefer to take up a little less space, maybe do it a little bit faster. And so I'm just going to remind you that we actually already know how to do this problem 7 that's written right here. We actually could have really done that at the beginning of this semester. Because on problem 7, we have this x that is attached by multiplication to the 2x plus 3. And before we knew about the box method, wouldn't we have just taken the x and distributed? Could put the 1 in front. And I think we could get our answer here. Let me do 2 different colors just to make it clear. 1x times 2x, 1 times 2 is 2, and x times x is x squared. And then same thing, 1x times 3, 1 times 3 is 3, and x just hangs out at the end. I think will give us an answer of 2x squared plus 3x. And again, you could have built a box here, right? We could have done x and then 2x plus 3, but these 2 multiplication problems, and I'll again show the colors, are really the same thing, right? That's the one that we did in red, and this is the one that we did in blue. So our final answer, of course, standard form, 2x squared plus 3x. This is a binomial. There are only 2 terms, degree of 2 and leading coefficient of 2. Now, it gets a little bit trickier, but not too bad, when we jump into problem 8. And the issue with problem 8, and I'm going to give you a couple ways to organize this, is that now we don't just have x that's multiplying by 2x plus 3. You have both x and a minus 2. So sometimes, and again, I'm going to give you 2, maybe even 3 options to do this right now, so just kind of split our paper here. Sometimes what you'll see people do is they'll say, oh, we could write this, because we know that x has to multiply by everything over there. You could write this as x times 2x plus 3. And then we also know that negative 2 has to multiply by that set of parentheses. So they'd say there's also a negative 2 that needs to multiply by 2x plus 3. And then you could distribute, right? Right here, this will give us 2x squared and 3x. And when I distribute the negative 2, that will give you negative 4x minus 6. As you combine your like terms, you get 2x squared, 3 minus 4 is negative 1x, and the minus 6 at the end, a nice trinomial. However, I find that students don't really like this extra step. They really enjoy combining that. So my preferred method, and your probably preferred method as well, is going to look something like this. You're going to take your x minus 2 times 2x plus 3. We're going to draw 4 separate arrows. My first arrows are going to be from the x, multiplying to everything in the second set of parentheses. X is going to go to 2x and to 3. So when we do that, x times 2x is 2x squared. X times 3 is 3x. Right? It matches what we did in red over there. And then you're going to take this negative 2 and multiply it times both of these as well. Negative 4x minus 6. When we combine like terms, we will of course get that same answer as before. Now I promised you 2 methods. I'm actually going to do this one more time too, because depending on who your teacher is, they may show you a third way, and I wanted to make sure you've heard of this third way, because some of your classmates are going to call it a specific name. You're going to be like, what the heck is that? Well, this third way is called FOIL, F-O-I-L. And I'm going to color code this and write this on the outside as well. And yeah, you might have enough room here. That's okay. So we're going to do F, which stands for firsts. Then we're going to do O, which stands for outers. Then we're going to do I, which stands for insides. And then we're going to do L, which stands for lasts. So what does that mean? Well, it's really trying to give you an order of how to multiply this binomial times another binomial, because that's what we're doing, right? A binomial times a binomial. And so it says the F in FOIL means multiply the firsts first, and the first is the first term in each binomial. So x times 2x, the first, gives us 2x squared. Then they say multiply the outers. So when they say the outers, they mean the numbers that are furthest to the outsides of the parentheses. So if you think of this as one big block, furthest to the outside on the left is the x, furthest to the outside on the right is the 3. So x times 3 gives you 3x. Then they want you to multiply the insides. So again, thinking of this as kind of one giant block here, okay, the insides are the numbers that are closest to the inside. That's the negative 2 and the positive 2x. So next, we would multiply this negative 2 times 2x. And when we do that, negative 2 times 2x, that's negative 4x. And then the last one is the lasts. And when they say last, they mean in each set of parentheses, multiply the last numbers together. And of course, that is the negative 2 times positive 3, which is negative 6. And you'll see we pretty much did the exact same thing up above. This still reduces to our same answer, 2x squared minus 1x minus 6. There is still a degree of 2, leading coefficient of 2. I generally do not teach FOIL. And the reason I don't teach FOIL is because of our very next problem, right? Our very next problem, FOIL doesn't work for. Because FOIL only has 4 steps, or 4 arrows. And this next problem will not have just 4 arrows. Can you see all of them? Right, so I'm going to rewrite this just to give myself a little bit of space here. All right, we know that everything in this first set of parentheses has to multiply by everything in the second set. I think that's all you really need to keep in mind. This x is going to have to multiply by 2x squared, negative 4x, and positive 3. This 3 is going to have to multiply by 2x squared, negative 4x, and positive 3. So I really just prefer to draw those arrows. It is up to you on how you want to show work, but you do have to show some sort of work. Arrows are great. This method, by the way, I usually just call distributive property. Some people call it the rainbow method. Can we see the cute little rainbows over here? Whatever sounds good to you, the arrow method. You can, of course, call it FOIL if there's only 2 terms or 2 binomials. That's totally okay. Let's multiply this out, though. X times 2x squared is 2x cubed. X times negative 4x is negative 4x squared, and x times 3 is 3x. Those are all my red arrows. Green ones, 3 times 2x squared is positive 6x squared, then negative 12x, and 3 times 3 is 9. Right? Now, one of the issues of using this distributive property is it's not as organized as the box method. We actually did, I think this may be exact same problem, didn't we, over here? Did we not? There we go. This exact same problem earlier, and when we used the box, it was so nicely organized it actually lined up our like terms here. That was pretty cool. So actually sometimes what you'll see people do when they're getting pretty used to this, and I'm going to erase this and then put it back in a second, is when they start to multiply the green arrows, they find where the like terms are and start to line them up. So 3 times 2x squared is 6x squared. So they look at these and say, which ones of these have an x squared? Ooh, that negative 4. And so they actually put their positive 6x squared directly underneath it, which I think is a clever method. And then 3 times negative 4x, they say that's negative 12x. 3 times 3 is 9. And then to finish this off, they just add straight down, which again I really like. 2x cubed has nothing to combine with, so it stays with 2x cubed. Although you could read this as negative 4 plus 6, start with the positive. 6 minus 4, that's 2x squareds. 3 minus 12 gets you negative 9x's, and then this little 9 just hangs out at the end. So if you're worried about that organization, this is a great way to do it. A lot of times they will line up very nicely like this. But if you don't want to do that, it's totally okay to put that at the end and just say plus 6x squared minus 12x plus 9, and then just identify your like terms, right? Negative 4x squared and 6x squared combined to make this, and so on and so forth. Okay? There is still a degree of 3, leading coefficient of 2. So last problem, I think. We've seen this one before, x plus 2 times x minus 1 times x plus 3. We don't want to make the common mistake, and I'll show you what the common mistake is. The common mistake is students will take, and I'm going to write this once more, just so I have room for those arrows. Students will take this x and say x needs to go here, 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 and here. And then the 2 needs to go here, 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 and here. And that's actually not correct. X plus 2 currently is only attached by multiplication to the x minus 1. So you can multiply those two. If you wanted, you could multiply those two, right? But you can't multiply this times both of those. That's not what's happening here, right? That would be like if someone asked you to do 3 times 4 times 5, and you said, oh, I can do that. 3 times 4 is 12, and 3 times 5 is 15, so the answer is 12 times 15. That's not how you multiply. You just multiply from left to right. You do 3 times 4 is 12, and now both of those are gone. You take the resultant product, the resultant answer, and you multiply those to get 60, right? We don't double multiply the first number. And to show you that we could do this differently too, I'm actually going to go backwards. Just for fun, I'm going to multiply 3 times negative 1 and 3 times x. And then I'm going to multiply x times negative 1 and x times x. That x plus 2 isn't getting touched for a bit, so it's going to hang out over here in parentheses, and we'll work the rest. So we had 3 times x, which is 3x, 3 times negative 1, which is negative 3. X times negative 1 is negative 1x, and x times x is positive x squared. Now be careful here, because technically you could now multiply x times the 3x and the negative 3 and the negative 1 and the x squared. That's 4 multiplication problems. And then you could do the same thing with the 2. 1, 2, 3, 4. You can multiply 8 more times. But why not simplify this first? Because I think if you simplify just by doing some really quick addition or subtraction, you reduce the amount of multiplication you have to do. I need to leave myself some more room here. And when I say reduce, let's do standard form as well. This x squared is going to come first. Like terms, 3x minus 1x is positive 2x, and then this minus 3 is at the end. So now, instead of doing all that extra 8 multiplications, now I just have to do once, twice, 3, and then we'll go with 4, 5, 6. So we have 6 multiplications to do instead of 8, which is nice. So x times x squared, x cubed, x times 2x is 2x squared, and x times negative 3 is negative 3x. I'm going to line these up. I think it'll come out pretty nicely. 2 times x squared is positive 2x squared. Okay? 2 times 2x is positive 4x, and 2 times negative 3 is negative 6. When we add all of these up, let's see if we can get our answer, and I'll just leave it over here. X cubed, 2 of something plus 2 more is 4. 4 minus 3, start with the positive, is 1x, and then negative 6. Leading coefficient, 1, degree 3. Well, now that you've had a ton of chances to practice and learn how to do this multiplication of polynomials in different ways, we're going to conclude class today with a quiz trade. Your teacher should be passing out note cards somewhere, and you're going to get one per person. Please carefully follow these directions. The first thing you're going to do is on the front of your note card, you're going to write your name on the bottom right. And you guys can decide which one is the front side and which one's the back side, right? Your note cards will probably have lines on one side and blank on the other, totally up to you. Okay? And on the front side, you're going to write out a problem. Now, you might want to hold off on writing the problem. I've actually left you some space up here for scratch work. Your problem needs to be multiplying a polynomial times a polynomial, and you can't use a monomial, right? It says polynomial of at least degree 2. So we need to have something with an x squared somewhere in there. And really, I guess we're talking about the answer here. So let's backtrack. Your problem has to have at least one set of parentheses times another. You can absolutely throw in some more if you want to add some complexity to your work. But you need to at least have that. And each of your parentheses need to have at least one addition, or you could have a subtraction somewhere in there too. You could do more. You could have 2 additions or 2 subtractions, whatever sounds good to you. We need to have at least one of each of those. Then you also need to have x's somewhere in there. So you could do like a plus x, then you could do a 2x over here. Sounds good, but there needs to be at least 1x in each of your parentheses. From there, you can pick any numbers you want, whatever sounds good to you. Doesn't matter. Last but not least, this space up here on your paper looks exactly like this. You need to go through and actually tell me what the final answer is in standard form. Right? So you can use any method you want. You can show as much work on here as you would like. You could go back to the box method and say, 4 plus x, 2x minus 8, multiply it out and write your answer in standard form. Great. You could use that double distributive property that we did on the previous page. That's awesome too. But you're trying to show all your work up here. You can also use the space on the sides. Once you've figured this out, then you're going to take this problem right here and write it on the front side of your actual note card. Just the problem. Should have your first and last name too. Then on the back, you are going to take your answer in standard form and put it there. Notice no work. So this work stuff here does not go on the note card. Not on note card. We don't want the work there because when people check their answers, because that's what you're going to be doing, you're going to be trading these cards. When you check answers, we don't want them to easily look at your work and just copy that down. You need to work on thinking for yourself. Then, of course, if the answer doesn't match when someone else does it, they have your name, they can hunt you down, and you can have a quick, cordial discussion about, hey, I got this, you got that. Can we compare work and see who's right? You figure it out. Maybe the person has to change their answer on the note card, write in pencil. Maybe you have to change your work to match that one. Totally fine. I have left you some space on the next page to get, I think, 12 or so classmates' problems done. Yours does not count because you've already done it on your paper. I also left you some information for your independent practice tonight. We discussed this at length on the opener, so I don't think you need me to go through that. However, there is going to be one problem on your paper tonight that we're going to discuss more at length on lesson 8.4 next class, where it's going to say a minus c squared. And we need to remember a square means multiplied by itself. So when you see a minus c squared, you do a minus c times a minus c, right? You'd set up the box, you'd have an a and a minus c, an a and a minus c, a squared, negative ac, negative ac, and then negative times negative is a positive, c times c is c squared. And then you just have to combine your like terms. So a squared doesn't have any like terms. Look at this diagonal. How do you combine these? Well, you put in those invisible ones. There is negative 1 of these ACs, and you're subtracting one more. There are now negative 2 of those ACs. We don't change the exponents here when you add or subtract. And then at the end, there's that positive c squared. So there you go. Actually just did one of your independent practice problems together right now. Nothing too bad. So good luck with that quiz trade. You're not going to get your own note card back until the end of class. There's more instructions on here. I'm excited to watch you guys be successful together. And definitely tune back in next class for lesson 8.4.